Last class we have discussed about the finite automata. So again we will see the formal definition of the finite automata. So it consists of 5 tuples: Q, sigma, delta, Q naught and F. Q means non-empty set of states. So where sigma is set of input alphabets, where delta is the transition function, Q naught is the initial state, F is the final state. So we have 2 or more final states. So Q, sigma, delta, Q naught, F are the 5 tuples that we have in the finite automata, where Q is the finite non-empty set of states. So we will discuss the formally. So where sigma is a set of input alphabets, delta is the transition function which maps the states, Q naught is the initial state where Q naught belongs to the empty set of states. F is the final state, even the final state that belongs to the set of states. So here, whereas in the finite automata we have 2 types of finite automata without output. So we will see the deterministic finite automata. Non-deterministic finite automata. So coming to the discussion, so first we will see what is DFA and what are the formal definitions of the DFA. So deterministic finite automata, simply we are writing it as the DFA. Even the DFA that contains the 5 tuples, like the normal finite automata, it consists of Q, sigma, delta, Q naught and F. Q is the set of states, sigma is the input alphabet, delta is the transition function. The one more important thing in the transition function, whereas in the DFA, the transition function that derives Q into sigma, that derives only the set of states that what we have the Q. That is the difference between the normal finite automata. The transition function difference is Q into sigma to Q. Now Q naught is the initial state and F is the final state. So this is the formal definition of the deterministic finite automata, but we have to remember the transition function, that is Q into sigma to Q. So we will see the example of how to construct the deterministic finite automata. See the construction of DFA. So we have to remember some points whenever we are constructing the DFA here. So deterministic finite automata, in the name itself deterministic, that means we can find the path whenever we are moving from one state to the another state. That means we have the single input symbol transition from one state to the another state. That is, we have the single transition on the same input alphabet, so that we can determine it. We are calling it as the DFA. So we will see the things. So whenever we have the construction of DFA, first we will take the examples. First one is design a DFA. Design a DFA where sigma equals to 0, 1 and accept the string strings that ends with, that starts with 1 and ends with 0. So that means we have to construct the deterministic finite automata whenever we have the input alphabets 0, 1, and we have to accept the strings that starts with 1 and ends with 0. First we will write the strings that starts with 1, ends with 0, that is 1, 0. Maybe starts with 1, ends with 0 means 1, 1, 0, 1, 1, 0, 1, 0, 1, 1, 0. So always we have to take the strings that starts with 1 and ends with 0. So based on these the strings, we have to construct the DFA. So for suppose whenever we have 1, 0, Q naught, I am taking it as the initial state. So whenever we have 1, 0, first we will transmit the input alphabet. The first one is 1. Next we have to transmit 0, 1, 0. That means it is started with 1 and ends with 0. So that means we have to end this state so that we have taken it as the final state. For the same thing, so whenever we have 1, 1, 0 string, 1, 1, 0, so we have to draw the DFA Q naught. So first we have transmitted 1, next we have to transmit one more 1, that is 1 and 0, 1, 1, 0. We have to stop the string, so we have to make it as the final state. Or otherwise we have one more, the referent like 110. We have to satisfy all the strings that starts with 1 and ends with 0. We have to draw the single DFA based on the given condition. So it has started with 1 and end with 0. So whenever we are drawing the DFA, it has to accept all the strings starts with 1 and ends with 0. Start with 1 and ends with 0. Whenever we have the DFA, we have to take the single transition for the single input alphabet. So here for Q naught, so we have taken it as the Q1. So the input alphabet is 1 because the given question is starts with 1. So next on Q1, we have taken the input alphabet 0. So because it has to end with 0, Q3 is the final state we have taken. So we have one more possibility to give the transition on Q1 even. So we have one input alphabet. So based on this DFA, we can write the strings 1, 0. So if we take it as the single transition, 0 transition, if we take the single transition 1, 1, 0, like 1, 1, 0, 1, 1, 1, 0, so on. So that means all the strings that accept starts with 1, ends with 0. Like that we have to construct the DFA based on the given question. So whenever we are writing the DFA, constructing the DFA, so we have to check that on single input alphabet. So we have to give only one transition. So for the Q1, so on 0 input alphabet, that is Q3, and 1 input alphabet, that is Q1. So you should not give like this. So like 0, you should not do like this, because 0 is transition to Q1 as well as the Q3. It is not accepting the DFA. So compulsory we have to give the input alphabet as 1. So we will see one more example. Construct a DFA. Construct a DFA accepting all the strings with AB. Accepting all the strings with AB. So given question is accepting all the strings with the AB. That's all. So not start with AB, not end with the AB. So there is no more condition. Just we have to go with the accepting the strings AB, like AAB, maybe the BAB, like AABA, BABA, and so on. So each and every string that has to accept with AB. So that is the given question. So we have to draw the DFA. So whenever we are drawing the DFA, how many number of states we have to take? That is the question. So given question is AB. So AB means we have the 2 alphabets. That means the length of the string is 2. So whenever we have to take the states in constructing of the DFA, so the states are length plus 1. That means here we have to take 3 states. We have to take 2 states to accept the string AB. So we'll design the DFA according to this. Q0 is the initial state. Always I am taking Q0, Q1, Q2. So that is not the condition. We can take any ABC or so and so. So here I am taking Q0 as the initial state. And accepting all the strings with the AB. So first I am taking it as A. Next taking it as B. So A, B. So we have to end this with AB. So the condition is accepting all the strings with AB. So here it satisfies. Maybe it starts with A or B. So no need of any condition, right? We don't have any condition. So I am giving it as B, because already I have transmitted A, an input alphabet. A we have transmitted from Q0 to Q1. So there is no chance to transmit it again, because it is a deterministic finite automata. So we are transmitting B on Q0. So on Q0 we have completed that both alphabets A and B. So next one, Q1 on input alphabet B we have transmitted to Q2, because the given question is satisfied with AB. So we have one more choice. We can give it as A, because we have already transmitted B. So we have one more chance to transmit A to Q1 to Q1. Based on this, we can give the transitions to Q2 also. So we have the possibility either A or B. So the given question satisfied or not, we have to check it based on these things. So we will write the possible strings B, A, B, A, B, A, B, B. So B, A, B, A. So B, A, B, and also B. So on. We can write many. So directly we can also write A, B. Whenever we have no self state, we can also take it as AB and so on. So whenever we have constructed a DFA, we have to check that the give whatever the drawn DFA is correct or not. So let us take any string that accepting the string with AB. So I am taking it as some A, B, A, B, A, B. So we have to check it as the string is satisfied or not. So we have the AB, right? So we have to check this. So first we will go with the delta of Q0 is our initial state, Q0, and the string we have taken it as A, B, A, B, A, B. So now we will check delta. Delta means the transition function. Q0 on input alphabet A. Q0 on input alphabet A. So our diagram that is moving to the next state as Q1. So we are writing it as Q1. So remaining as is the string. Next, Q1 on input alphabet A. Q1 on input alphabet A. The transition that is the next state to Q1 itself. So delta Q1 comma A, that is Q1. So we have written Q1. The remaining string is as it is. So next, Q1 on input alphabet B, Q1 on input alphabet B. So the next state is Q2. So writing it as Q2 and remaining string like AB, AB. So next we have to check Q2 on input alphabet A. Q2 on input alphabet A, that is the same self state, that is Q2, delta of Q2, and the remaining string is BAB. Next, Q2 on input alphabet B, Q2 on input alphabet B, that is Q2 itself, and the remaining string is AB. And Q2 on input alphabet A, Q2 itself, the next state is, the remaining string is B. Delta of Q2 comma B, Q2 on input alphabet B, we have the Q2 itself. So whenever we are checking these type of the strings, for the strings, so whenever we have to check the drawn of the DFA, we have to remember that we have to reach it to the final state. So as you are aware that Q2 is the final state here, so we have reached to the final state. That means whatever the DFA that we have constructed is correct. So like that we have to check the construction of the DFA.